So this is screw gauge, and its precision is more than the vernier caliper. Okay, so vernier calipers, most of the vernier calipers, they have got precision up to 0.1 of mm, okay, 1/10 of a millimeter. Screw gauge is more precise. Okay, so it can measure up to 1/50 or 1/100 of a millimeter. Okay, so depending upon its construction. So this is a screw gauge, and the object whose width or length you want to measure, you will keep it over here. Okay, so these are various parts of the screw gauge. This one is known as stud. This is the frame. Okay, this one is known as, this is called as thimble. This is the ratchet, and obviously you can spot the screw over here. Okay, you can see the screw. All right, so now what will you do? So you will keep your object over here. Okay, let's say I want to measure the thickness of some object. I will keep it over here. Okay, can be anything. So now I will tighten the screw. So how will I tighten it? So I will move this ratchet. Okay, so move it like this. I will fasten the screw. Okay, till the time that object doesn't fall, right? So then it will show some reading. So this is known as, this is the main scale. I'm sorry, this is the main scale of the screw gauge, and this is the circular scale. So you can see there are readings on the main scale, and there are some markings on this circular scale too. So can you see them? Yes, no? Just the
Yes, sir.
lines, just the lines, not the exact numbers. You can see the lines, right? So now when there is nothing, okay, in between the screw and this body, okay, this part of the body of screw gauge, then the this end of the screw and this end of the stud, we can say, they are intact. Okay, so now in that case, the zero on the circular scale, it will match with this reference line of the readings. Okay, so then in that case there is no error. Now you put something, okay, you put something over there whose thickness you want to measure. So then what will happen? So this main scale, okay, it will get shifted, the screw will get shifted. Okay, how do you do that? So you will pull this ratchet outwards. Okay, so you will move the ratchet in order to create space over here. So this screw gauge, this thimble, it will move towards right. Okay, and it will show the readings on the main scale then. Okay, so if there is nothing, then the readings on main scale will be invisible. Okay, so this side of this thimble, it will exactly overlap your zero. All right, but when you put something, over here whose distance, sorry, whose length you want to measure, then what will happen? Your thimble will move towards right. Okay, so this part of the main scale will be visible. All right, and then you can take main scale reading from here. Okay, so whatever line that you can see, that will be your main scale reading, and then on circular scale, one of the line on the circular scale, it will match with this reference line. All right, so that will be your circular scale reading. So is it clear?
Yes, sir.
Yes, no?
Yes, sir.
All right, so then you take main scale reading from here and circular scale reading from here. So one of the lines of the circular scale, it will match with this reference line, okay, on the main scale. All right, so that will be your circular scale reading. So now the important thing about this screw gauge is the pitch of the screw gauge. Okay, so what is this? What is the pitch? So you move this ratchet, okay, you rotate the ratchet, then what happens? the screw moves horizontally. All right. So when you rotate this ratchet by 360 degrees, what will happen? The screw will move by the distance equal to distance between two threads, and that is known as what? The pitch of the screw gauge. Okay, it is known as, that distance is known as pitch of the screw gauge. Okay, and then you can have some markings on the circular scale. So let's say you rotate it by half. How much distance will it cover? It will cover half of the distance between the two threads. Okay, and how much is the rotation then? It is 180 degrees or pi. Okay, so how many markings can you have on the screw gauge? Okay, on the circular scale. So you will have 50 to 100 markings on the circular scale. Okay, in the problems it can go up to 200 or something, but you will have 50 to 100 markings on the circular scale. So what does that mean? One rotation, it is divided into how many parts? 50 parts to 100 parts. So if you have 50 markings, then you are dividing the 2 pi by by how many parts? 50. If you have 100 markings, you are dividing 2 pi by 100. Okay, and that is exact number of parts in which you are dividing this horizontal distance. Okay, which horizontal distance? The distance between two threads. See, when you rotate it fully, when you rotate it with one revolution, one rotation. So when you rotate it by 360 degrees, how much distance does it cover? It covers this much distance. And how do you measure that distance? On the circular scale, so it is number of markings on the circular scale. Okay, so when you rotate it by 360 degrees, it will cover one rotation, and let's say there are 100 markings, so your reading will be what? 100. Okay, your reading will be 100. So if you rotate it by half rotation, that is 180 degrees, then it will move this much distance. So your reading on the circular scale will be how much? 50, right? So from here to here, how much is the distance? It is 50 marks on your circular scale multiplied by the least count of the circular scale. Got it?
Yes, sir.
Yes, sir.
Okay. So what is the pitch? When ratchet is given one complete rotation, the distance through which the screw moves, okay, it is also the distance between two threads of the screw, so that is known as the pitch of the screw gauge. Okay, and how do we find the least count? So as we discussed, the least count of the screw gauge, it is this pitch, the distance through which the screw moves in one rotation, divided by the number of division on the circular scale. Okay, that is the minimum distance that you can measure. Okay, so it is the distance through which the screw moves when you rotate the ratchet by 360 degrees. So this much is the distance. Okay, and on circular scale you are dividing that into n number of parts. So what will be least count? It will be this much distance divided by the number of markings on your circular scale. So you got the least count?
Yes, sir.
Yes, sir.
Okay, so for an example, let's suppose the pitch is 1 mm. Okay, so screw is designed in a way that when you rotate it with 360 degrees, what happens? It moves by the distance of what? 1 mm. And then your circular scale, let's say your circular scale has got 100 readings. Okay, 100 markings. Then what will be your least count? The least count will be 1 divided by 100.
Yes, sir.
Okay, so then, all right. So now I will try to draw something. So this is my screw gauge. Okay, and this is the screw. Then this is my main scale. This is the zero of the main scale, and I am putting some object over here. Okay, I put some object over here, and this is, let's say, 1 2 3 4 5. Okay, so this is how much? This is 0.5 centimeters. So on main scale, 0.6 is visible. That means 6 mm is visible. Okay, 0.7 is not visible. Okay, so 0.6 is visible and the seventh mark is not visible. So then you have to see how many marks are there over here.
4.
4 marks. Okay, the 4 marks, fourth mark on the circular scale, it is matching with this reference line.
Yes, sir.
Okay, so what will be
Yes,
your
sir.
reading? Your reading will be the reading on the main scale reading plus circular scale reading multiplied by the least count. Okay, and if this is divided into 100 parts, what will be the least count? We have seen it is 1 divided by 100.
1 by 100.
Okay, if each is divided in 100 parts, then the least count is 1 divided by 100. So this is equal to what? Main scale reading is 6 mm, right? This is 1, 2, 3, 4, 5, 6 mm. Okay, this is 6 mm plus this is circular
4.
scale reading is 4 multiplied by the least count, and least count is 1 divided by 100. Okay, so what will be your reading? It will be 6.04 mm, right?
Yes, sir.
Yes, sir.
So instead of 4, let's suppose it matches with 40. Okay, 40th mark on your circular scale matches with the reference line. Then what will be your reading? It will be 40 multiplied by 1 upon 100 over here.
6.4 millimeter.
It will be 6.4 or 6.40.
6.40.
Okay, we have to keep in mind the resolution of the instrument. Okay, so if you write 6.4 millimeter, that's wrong. Why? Because the resolution of this device is more. Okay, so this 0 is significant. All right, so we have to always keep
Yes,
that in
sir.
mind. Okay, so this is simple.
Yes, sir.
Okay, so then just like vernier caliper, there can be some zero error in the screw gauge also. So let's say you don't put anything, okay, you don't measure anything, then the zero of the screw gauge, it should match with this reference line. Okay, reference line on the main scale. All right, so if this is the case, then there is no error. Okay, no zero error. But then now let's suppose you have some screw gauge whose zero falls like this, it is below this uh, reference line of the main scale, then there would be some error. It would be positive or negative?
Positive error.
Will be positive because you are not measuring anything. Still, your circular scale is showing some measurement. Okay, your circular scale showing how much measurement? 1, 2, I guess. Okay, so the second line on the circular scale, it matches with the zero of it matches with the reference line. Okay, all right, so that means the error over here is how much? It is 2 multiplied by the least count. Okay, this is positive error, so we have
Okay,
to
sir.
subtract it. So similarly, we can have negative error too. So here, now 0 is above the reference line. Okay, this 0 is the above the reference line of main scale. So in that case, how much would be the error? This is negative error. How much is it? 1, 2, 3, 4. Okay,
4.
so it is minus 4. It is minus 4 multiplied by the least count. You got it?
Yes, sir.
So this error,
Yes, sir.
good. So this error is 2 multiplied by, okay, 2 multiplied by the least count, which can be 0.01. Okay, so in the example that we have taken, it's 0.01. So it is equal to 0.02 mm. And in this case, it is minus 4 multiplied by 0 error is minus 4 multiplied by the least count, and that is equal to what? Minus 0.04
0.0.
mm. All right. So is it clear?
Yes, sir.
Yes, sir.
Okay. So only this much is the theory of screw gauge, and now we can see some problems. So see, I told you recently there have been many questions based upon the vernier caliper as well as the screw gauge. Okay, so there was a question in NEET 2019, I guess 2018, based upon vernier caliper. Okay, and here you can see NEET 2020 question. This is based upon screw gauge. Okay, so this topic, the measuring instruments, it has gained some importance as far as NEET is concerned. Okay, so let's see this question. A screw gauge has least count of 0.01 mm. So what is given? Least count is given. It is 0.01 mm. Then, and there are 50 divisions in its circular scale. 50 divisions on the circular scale. The pitch of the screw gauge is. It's very simple question. What to do?
Pitch is equal to least count multiplied by number of divisions in circular
Right.
scale.
So pitch is equal to least count multiplied by number of divisions on circular scale. Or so because I don't like to memorize many formulae, so I will write least count is equal to pitch divided by the number of divisions on circular scale. Okay, and because I want to find out pitch, okay, I will take n on the other side. So pitch is equal to 0.01 multiplied by n. So how much is that? It's 50. N is equal to 50. So 0.01 multiplied by 50. So it is 0.50
50.
mm. Okay. So this much is the pitch, right?
Yes, sir.
This is the answer. Now, is this correct or not?
Wrong only. 0.50 only exact answer, but option it's only given, so it's answer.
Okay. So actually, this is correct.
So, but 0.01 means its resolution is up to 2 decimal point, no?
Okay. So here it doesn't matter how much of, see, whether they write 0.50 or 0.5. If you want reading in terms of screw gauge, then it will be 0.50. Okay. So this is not measured by screw gauge.
Okay, sir, okay.
Okay. The pitch. What is the pitch? This is the pitch. Okay. The distance between two threads of the screw. Okay. So it's not like they are putting the two threads. Okay.
Yes, sir, now I can
They
understand.
are not measuring anything. They are not measuring this. Okay. Using the screw gauge. Got it? So it doesn't matter whether they are writing 0.50 or 0.5. So if they
Yes, sir, got
claim,
it, sir.
yes, if they claim that the measurement is taken using the screw gauge, then you can say it's wrong. then definitely it would be wrong. Okay, they are not doing so. They are not claiming that the measurement is taken using this screw gauge. So that's why this is correct.
Okay, sir.
Pradnya, agree with this or not?
Yes, sir.
Okay, you have right to disagree also. Okay, this is science. Okay, so whenever you disagree, you can tell me, and there can be a discussion. Okay, so questioning is the first step. Nobody has authority in science. All right, let's let's see this next question. If the screw on the screw gauge is given 6 rotations, so how many number of rotations are given? 6 rotations. It moves by 3 mm on the main scale. Okay, so the main scale gets shifted by what? The thimble gets shifted by 3 mm on the main scale. Okay, or you can say the screw moves by 3 mm. If there are 50 divisions on the circular scale, the least count of the screw gauge is. So now I want you to tell me what to do.
Option C.
Will be option C. Okay, but I am asking how will you find it out?
6 rotations, 3 millimeters. So one rotation is 0.5 millimeter
Exactly,
and 0.5 by 50.
exactly. Very good. So it is the distance moved is 3 mm in 6 rotations. So the distance moved per rotation is equal to what? This distance moved in 6 rotations divided by 6 rotations. So this will give you the pitch, okay, which is equal to 0.5 mm. And then there are 50 divisions. So 50 divisions on the circular scale. So your least count is pitch divided by the number of divisions, okay, which is equal to 0.5 divided by, there are 50 divisions, so 0.5 divided by 50, it's equal to what? 0.01 centimeters. Very good, Pradnya. Okay, this is simple. Lawrence.
Yes, sir.
Okay, let's see this next question. So this question is, using screw gauge of pitch 0.1 centimeter and 50 divisions on circular scale, the thickness of an object is measured. It should correctly be recorded as. So this is from JE 2020. It's not from NEET, but it's simple question, can be asked in NEET too. Yes, answer. See, this is simple. We discussed about this yesterday. See, using the screw gauge of pitch 0.1 centimeter and 50 divisions on the circular scale. First of all, let's find out its least count. Okay, least count is pitch divided by the number of divisions on the circular scale. So the pitch is 0.1 centimeter, 0.1 centimeter, and there are 50 divisions. Okay, so this divided by 50 will give me what? Or I can say, if I multiply and divide by 2, it will be 0.2 divided by 100. So 0.2 divided by 100, that means it is 0.002 centimeter. Is it correct?
Yes, sir.
Okay, so now can you tell me the least count of this device is 0.002 centimeters. Okay, and it measures something, it measures thickness of an object. It should be correctly recorded as. All right. So see, you have got some least count. Okay, the minimum reading that can be taken by this device is 0.002. Okay, so can I measure this much distance using this device 0.002? Can I measure? Yes, right. That's the minimum distance which can be measured. Can I measure 0.003 using this device?
No.
Okay, I can't measure because the least count is 0.002. The next reading, okay, the next line that will show that the reading the next line will show will be what 0.004. Okay, so it can't show 0.003 if there are two markings. Okay, if two markings of this circular scale match with the reference line, then the reading will be what 0.004 centimeters. If three markings match, then it will be three times the least count.
0.006.
Okay, four markings, it will be 0.008 centimeters. So can you see something? It can't measure this. Okay, it can measure 0.002, 004, 006, 008. Okay, it means that it cannot measure this thing, and this thing. Okay, yes or no?
Yes, sir.
The,
Yes, sir.
the reading that this device will give, it will be always in multiples of the least count. Okay, so some whole number multiplied by least count. Got it? So this reading is not possible because you are having an odd number over here, and the least count is even. So it will be anything, any number multiplied by the least count will always give you what? The even reading. Okay, so at this point, at this digit, there can be an odd number.
Yes, sir.
So,
Okay, so what is the answer?
Option B.
Option B is the answer. Simple.
Yes, sir.
You got it, Pradnya, or is there a question, a doubt?
sir, got it.
Okay, good. So then let's see the next question. A student measured the length of a rod and wrote it as 3.50 centimeters. Which instrument did he use to measure it? Okay, so these are the options. A meter scale. Can you get this kind of reading using a meter scale?
No.
No, sir.
Okay. Vernier caliper, where the 10 divisions in vernier scale match with 9 divisions in main scale, and main scale has 10 divisions in 1 centimeter. So is it possible to measure this thing using a vernier scale like this? Okay, what will be least count of this vernier scale? 10 divisions on vernier scale, and main scale has 10 division in 1 centimeter. Okay, so the least count of main scale is how much? It is 1 divided by 10.
Yes,
Okay,
sir. 0.1.
0.1 centimeter, and the vernier scale has 10 divisions. So that means how much is the least count over here? It is least count, or one division of your main scale divided by number of divisions on vernier scale. So it's equal to how much? 0.1 centimeter divided by the number of divisions. Okay, so number of divisions is 10. So it is 0.01 centimeter. Okay, so is it possible to measure this thing using this kind of vernier scale?
Yes, sir.
Yes, no?
Possible, sir.
See, the precision of this device. So from the reading, we know now how to measure the, sorry, how to figure out the precision from the reading. So your reading is 3.50, right? That means precision is 0.01. Okay, your your device is precise up to this digit. Okay, this reading 0.01 is the precision. Okay, so you need a device whose precision is equal to what? 0.01. and this vernier caliper, okay, this vernier caliper has got that much of, that much of precision, right?
Yes, sir.
Yes, sir.
Okay, so do we need to check these options?
No, sir.
Yes or no? In exam, of course, you will not check, right? But if you want, we can check it now. Okay, a screw gauge having 100 divisions in circular scale and pitch of 1 mm. This is very simple. The least count will be what? For third one, the least count is,
0.01.
it will be 1 mm. Yeah, 1 mm divided by 100, 0.01. But what is this? This is mm. If I want to convert this in centimeters, it is equal to 0.001 centimeters. Okay, so this has got much more precision compared to this reading, right?
Yes,
So
sir.
for this reading, that much precision is not required. Okay, and screw gauge having 50 divisions in circular scale and pitch of 1 mm. So the least count of this last one is equal to what? 1 mm divided by 50. So it will be 0.00
0.02.
centimeters. So this is also much more precise. Okay, so this is, it is not this device, it's not this device. So it is,
Sir, 0.02 or 0.002?
it will be 0.002. I wrote centimeter over here.
Okay, sir. Okay.
Okay, 0.02 in millimeters, but if you want to convert
Yes,
it
sir.
in
Yes, sir. I
centimeters.
didn't see the unit.
Okay, so you got this question? Is it, it is clear?
Yes, sir.
Yes, sir.
Okay, so let's see the next question. And the next question is, a student measured the diameter of a small steel ball using screw gauge of least count 0.001 centimeter. Okay, so good thing is least count is given. The main scale reading is 5 mm and the zero of circular scale coincides with 25 divisions above the reference level. Okay, so it coincides with 25 divisions above the reference level. All right, if screw gauge has a zero error of minus 0.004 centimeter, the correct diameter of the ball is. So what will be the correct diameter? It is the reading, let's say D is equal to main scale reading plus the circular scale reading
Circular scale reading
multiplied
multiplied
by
by least count
least count,
plus
but
zero
there
error.
is zero error and it is negative zero error. Okay, so we have to subtract the zero error, right? So it is minus the zero error.
So negative zero error means we have to add, no?
Yeah, so I will explain what I'm saying. Okay,
Okay, sir.
so what is main scale reading? It is 5 mm, right? Circular scale reading is 25 divisions above the reference level. Okay, so how much is that? Is 25 multiplied by the least count is 0.001 centimeter.
0.01.
So 0.001 centimeter. Okay, and minus the zero error is minus 0.004. So I will substitute that over here. Okay, so this is what I was saying. So you can always
Okay, sir.
subtract. You can always subtract the zero error. Okay, if the zero error is positive, then you will subtract it, right? It will get subtracted. But if you put the zero error with the negative or positive sign, you will always get correct result. Okay, so it is minus of
Yes, sir.
minus 0.004. All right.
Yes, sir.
Okay, so then it is 5 millimeters. So the options are in centimeters. So we have to convert this one in centimeters, right? How much is that? It's 0.5 centimeters plus it is 25 multiplied by 0.001. So it is 0.25, and this is plus, minus minus becomes plus. So 0.004. And what is the total? 0.5.
0.529.
0.529. 0.529 centimeters is the answer. Okay. All right. So a screw gauge has 50 divisions on its circular scale. So number of divisions on circular scale we denote by capital N. It's equal to 50. Then the circular scale is 4 units ahead of the pitch. So this is the zero error. How much is zero error? It's equal to 4 multiplied by the least count. Okay, so least count we don't know right now. Let's find it. Upon one complete rotation, the circular scale, a displacement of 0.5 mm is noticed on the pitch scale. Pitch scale means what? The circular scale. Okay, so pitch is 0.5 mm, and question is the nature of zero error involved and the least count of the screw gauge. So this is simple. What will be the least count? It's 0.5 divided by
50.
50. Okay, the least count is 0.5 divided by 50. How much is that?
0.1 millimeter.
0.01 millimeter, right?
Yes, sir.
Okay, so you got the least count, and the zero error is equal to 4 multiplied by the least count. Least count is 0.01, so it is 0.04, okay, of millimeter. So it's not matching. Did we do something wrong in this question? The nature of the zero error. They are not asking the value of zero error, right?
It will be negative zero error.
It will be
Negative zero error.
negative or positive. So you can see it over here. So this is, see, in this case the zero has gone 2 places down, 2 places ahead. Okay, this is ahead, right? 2 places ahead. So second place, second mark on this circular scale, it is matching with this. If it goes 4 places down, down means ahead. Okay, so fourth mark on the circular scale, it will match with the zero. I mean the reference line.
Yes, sir.
Yes, sir.
Okay, so this is positive error. So now our reading is 0.01 mm. The least count is equal to what? 0.01 mm. So let's convert it in micrometers. So it's equal to 0.01 multiplied by what? 10 raised to 3?
Yes.
Yes, sir.
10 mic.
10 millimeter.
0 point, yeah, this is okay, 10.
10.
It will be 10 micrometers. Okay, so 10 micrometers is your answer. So which answer? Sorry, which option?
B
B.
option.
Option B. Okay, this is correct answer. All right.